Hello all, I'm Berend from the Netherlands. Recently joined AI for Finance. There was a request by Hunter Jensen to do a video tutorial for the demo on multi-crypto trading notebook. So here I am, and if you want to find this thread, it's in the crypto trading DRL channel, and it's quite a recent message still about January 26th. So if you want to find this, I'll be posting this probably there. So open the link to GitHub, and this is where you will end up in the GitHub, and open it in Colab, and then it's better to make a copy in your own drive, in my opinion. I already did that, so I'm gonna close it, and this is where I will start off. I commented out the installs, but so you need to install all of these packages. I'll go shortly through them. Well, FinRL Meta, of course, it's the one of the main repos on the AI for Finance GitHub, and then it cds into the FinRL Meta and installs parts of the FinRL Meta, namely ElegantRL and FinRL Library. iFinance stock stats, looked it up. It's just for how do you call it? Indicators. So it's a extra package for Python for indicators. Alpaca Trade API is not required in this tutorial, but it is to eventually do paper trading on Alpaca. It's quite interesting to look at. I deployed a bot on this website, and it's really nice to test out your current trading strategies, which you should create by, for example, this notebook. Ray is for the reinforcement library, scalable reinforcement learning lib. Also in this tutorial, which I will not be using, I have still never used it. I'm using the ElegantRL library mainly. Then moreover, what is this? LZ4, no idea. LZ4 Python. Compression library, okay. TensorBoard, yeah, you can look it up. It's for looking what's happening with your during trading. Trading calendars is to get the right dates for trading. Words is a database. RQ is a database, for example, where you could, so are all data sources. SQL Alchemy, it's for probably SQL Alchemy. Database toolkit, okay, and to share. Talib is a really nice one. It's for indicators, and I really like Talib because it offers a huge range of indicators. It's quite a little bit trickier to install, but it's fine. This is all just some Linux commands. Okay, so I already ran this. So it's already installed in my current runtime. So I'm just gonna comment this out, and that's it. Then first import cryptoenv. It's the cryptoenv is stated below already in code directly. So normally you could skip this, but in this tutorial it just shows you exactly how this crypto environment looks like, and yeah, you should be able to change certain aspects of your environment accordingly to where you want to be deploying your trading algorithm eventually. I'll explain more of that later. So this whole import is just could be your. It's not necessary to repeat the whole code down below. Then we have the functions for training and testing. I have some extra stuff over here compared to the original notebook, and also explain later why. Um, then we have, so here's the train function. Let's keep it a little bit an overview first. So this is the complete train function. As I said, we will not be working with this reinforcement library from Ray, and also not with the stable baselines free. That is your own choice. I like to stick to the elegant RL packages. So we will just limit ourselves to this part of the code for now. If you want to do a deep dive yourself into the other libraries, be my guest, but I don't know personally a lot about them. Then we have the test. So first we train on data, we let the agent explore and exploit and try new trading strategies and whatsoever. And in the testing part, we used only the learned strategy to actually test how good our strategy or policy is after training. Then you have the environment. This environment should be an exact copy of where you are going to deploy your live trading algorithm. So if you are, for example, on Alpaca, you will have, let's say, 0.001% spot fee. So if you buy a thousand Bitcoin, you will pay a $1 fee. Yeah, and this differs, for example, already for Binance and KuCoin and whatever place you want to trade your cryptos on. So it's good to remember that your environment should eventually be an exact copy of where you want to be trading. Alright. Next, actually now everything is already done. The ticker list is where you want to, which coins you want to be trading. The environment is what I just explained. The train start date, the data used for how long you want, for when you want to start the trading and end the trading, which cannot overlap with your testing data, because otherwise you would like be overfitting to your train data and test during the test, which is really unfair. Technical indicators, like I said, you can download those on Taleb. For now, we just stick to these very easy ones. If you want to know more about them, you can do MACD, Investopedia, and yeah, read some more about this. I will not dive into this. This is very common knowledge, and it's very well explained on Investopedia, as well as so the other technical indicators. Then the trading function is here used and deployed, and here is the testing function, and eventually you have the value of your vector with the value of your account. And then we just simply plot. So now I'll try to dive a little bit deeper into the functions individually. So we actually we simply have training, then testing. We have the environment, the literal environment in here. Then we simply have to set the parameters, and we can start. Then we train, do the actual training, test, and then we have the results and we can plot. So it's not, it's not that hard. Okay, so back. Let's look at the train function in more detail. So the train function takes the train start date, train end date, the ticker list, which is the coins you want to be trading, which should be could be Doge against USDT or Doge against BTC or Ethereum. You can check if they exist on the actual platform where you eventually want to trade. The data source determines or a switch in which in the data processor, and is going to determine where the data is coming from. The time interval is if you know about trading candles, is the width of the candle. So if you have 30-minute data, you will have data every 30 minutes. If you have 2 hourly data, you have data every 2 hours, etc. Technical indicators, as explained before. DRL lib, don't know exactly what that's doing here. Let me check quickly. Okay, it's the sorry, it's the deep reinforcement library we are using. So we are only using elegant RL in this example. So then the environment is the environment which is hard coded below. Model name is it's PPO. So that determines which actual optimization algorithm we are going to use. The current working directory is where you save your train model. URL params is your reinforcement learning parameters. So learning rate, batch size. Your gamma is how much you care about future rewards instead of getting rewards now. If you put your gamma at 0, it will only care, which it's not possible, or 0. Or at, let's say, a low number. You will only care about getting rewards as quick as possible. That could be interesting in trading on very low time frames. I'm not sure about that. Don't hold that against me. The seed is which random randomness it's gonna take in. If it's for the reproducibility. So if you have a random number, you're gonna get the same random numbers with the same seed, and it doesn't matter how many times the random number is used throughout the whole algorithm. It's always the same. So this for reproducibility. Net dimension is of your neural network, which determines what's the best action eventually. Target step, I'll talk about that a little bit more. So how many times you will pass through the data set. Eval gap is a pause between the I believe it's a pause between the training sessions, and evaluation times I don't actually know. So back up. Okay, so in the original code is this part. You will see it tries to get a data processor. Let me run this. It will try to define a data processor. If you hold Control and click it, you can go inside of it, and here you see the init. So actually what you see here is that the init only takes data source, start date, end date, time interval, and quarks, which are like extra variables which come at the end. So the original code, there's a lot of extra information in the data processor, and if you look at this initialization, just copy it over here and put it above the original code, then you see actually this line of code in line 15 is missing a lot of necessary information which should come from the train function. So I changed that to this line. I'll keep it at 15. Line 15. I changed that to this line, accordingly to what was in the data processor, and then and that will make it. That will fix that particular line. And then I also ran into the same problem with the data processor run function, which is also here in the data processor, but scroll down a bit and it will be here. And I saw also for this run function that the original didn't correspond to what was necessary, because it has start date, end date, and time interval, and this is already given to the data processor in the init function, so we don't need to give them to the run function a secondary time. So this was the old code, and I replaced that with this part, which will fix this function. Right. So, and the same accounts for the test. It's actually exactly the same piece of code. So you can just copy that and put that in the test function as well, and then it will work. So if you change to this particular piece of code, then it will work. Okay, let's go back to what we're doing here. So the data processor, you init it. It determines the data source, which is in our case Binance. Then you see a lot of data sources here. So you can get from Alpaca or Joint Quant or Rise Quant, Words, Yahoo Finance, Binance, 2Sharp Pro, never heard of it, but it doesn't matter. We have Binance, so the processor will be Binance. Now, I wish I could get into this processor. Give me a sec. Okay, so I found where this processor is. For some reason I cannot just control this. There's some missing imports. I don't know why, but I know I can find it myself. It's if you go into your folders, go one folder up, which you cannot see in the video, and then go into FinRL meta. And we're working here, so we're going into FinRL meta. Then we go into processors. Binance data processors, into this folder, processor Binance, which is this eventual processor. So we're using this processor because the data source is that. Then the Binance processor goes in here. Then we run, and then we will get data. Let's see. Yeah, sorry, I had to look for it a little bit. So then we from here we run the data processor. So we go into the data processor, this function. Then some value error because Binance is the only data that supports 1 second data. A cache there, and so a path to it, and some, I don't know exactly what this is, but the most important part is here. So self.download data. So the data processor is already set, which is this processor Binance, which you can find in your files here. And then it says download data. Here it sets the start time at the requested format, the end time, sets stringifies that particular thing and sets that as part of the class. Here you see the API. You don't need any API keys or secret key to get into this fee-free clients, which is very nice of Binance. The interval is again the time interval, and the limit is the amount of candles you can download. So I think the limit indeed is 1440 via Binance. Then some special handling for 1 second data, and then it will start downloading the history data for each ticker, and it will put that into the data frame, and this is eventually only the OHLCV data. So I hope you all know what that is. So it's the open, high, low, close volume data. So for example in this figure right here, in a figure right here for a candle, the opening price would be the price of it would be this level, the lower part of the rectangle. The lower is the end of the wick, so the bottom. The higher is the open, high, low, close. So the highest is the highest wick, lowest is lowest wick. The close is the top of the big rectangle, and the volume is the amount of traded in that particular data. If you have this data, you can basically construct from there all technical indicators you can imagine with the Taleb library. So that's why first here we just simply download the data, and then from the data will be downloaded. There's a function in the data processor which cleans the data. Where is it? Self.clean data. Here. It does something. Let's see. Clean data. Okay. And this Binance processor has a function normally called clean data. It's always a bit looking around and hoping that you find what you're looking for. So here is drop NA, and actually this is already in performed in the download data function. So probably that's why it commented here. There's no adding technical indicators for the Binance processor yet. There's no turbulence, it's not supported yet. Fix is not supported yet, so it all doesn't matter. But okay, so let's get back. Run. It's downloaded. It's cleaned. And then there's some handling of where to dump the files. Then we have a self.add technical indicator list. And here the technical indicators are added in this function, add technical indicator. The technical indicator list is that processor.add technical indicator. So now we go back into the processor, and yeah. Okay, I'm sorry. I don't know. Like the Binance processor changed a lot for me. The way I personally did it is, yeah. So sorry. I figured it out. I like to add these technical indicators, and this was commented out in the downloaded code as well. So it was only downloading the OHL survey data. These are quite basic technical indicators, and yeah, would like to add them. So I just commented this out, and if you comment it out, it'll give you an error where it doesn't know what these are. So these technical indicators are. So I imported from Talib. I imported them. This is the way I did it, and now it runs. So I rebooted my runtime, and no, I didn't reboot my runtime. I went to the train function, ran all above with the installation part commented out, so you don't have to redo the whole installation, or it's just requirement already satisfied. And then it will actually work, but we're not there yet. So yeah, we were here. So here it adds technical indicators, which is a function in the data processor, which is then the self technical indicator list is set as what you provide as in the technical indicators, and which is stated in the train function, and then it goes into the processor, add technical indicators, and that is this function, and then it will add the MACD and LC, CCI, and DX to the final data frame, which is quite desirable. I don't know why they changed it and what for, but I'm gonna look into that in my own time. Yeah, so we're back. The technical indicators are added, and the price array, which is the complete array of all the prices of all your cryptos at each data point. Same accounts for tech, so this is your technical indicator array, and then we have a turbulence array, which is just 0, as this is not a thing yet in the Binance processor. It's like here you see add turbulence, turbulence not supported yet. So then also tag none positions checks for the tag array where where they are non-existent, and just sets them at 0 so they don't ruin your training process. Alright, so now this returns our data, the prices, the technical indicators, turbulence. Now we can go back to the notebook. We can go back to the train function, and now we are at line 14. So then we package this into data config notebook, which is expected from the environment, which we will get at later. Fetches the current working directory from the quarks, which are the extra arguments. If you want to look into that, it's a Pythonic thing. The DRR lab is elegant RRL. Break step is the where we break up the training process. The ERL params are all the parameters stated for training. So here they are. It's the learning rate, batch size, gamma, blah blah blah. This is okay. So now we're gonna get a little bit into the model, and let me see what I want to tell here. Alright, first we're gonna find this particular agent. So it's the DRL agent ERL. So it's DRL agents elegant RL models import DRL agents DRL agent ERL. So let's see. So the elegant RL models DRL agent ERL. So as DRL agent ERL. So it's this class. Okay, we found it. Now, okay, what do I want to say about this? We are initiating this class with the init values, the environment, price array, tag array, turbulence array. So that's what we do here. Then we have the agent. Then we have a function get model. So the model name was PPO, as stated here, and this is a choice. There's many different agents out there, and PPO is just one of them. And in this class, it contains all of the. It's somewhere all of the agents are hidden. Let me check. All right, back. So here you have this function get model, where the env config is given, the env is set, the number of environments, and here is the models name, models constant in this class. Here it says models either DPPG, TD3, SAC, PPO. These are all agents, and well, error if it's not there. And then we have this line. So we can go up and we see what arguments are, and arguments is from elegant RL config. So we go into the config, so control click, and here it actually sets all the parameters for all the arguments for training session, and so it returns the model. Let's see. So basically all the model arguments are coming from here, and then it will sets if it's an on or off policy agent. You should look into that yourself, and sets all the ERL parameters and returns the model. That's where we can get back to. Then this returns to the train function, and here in the next line we go back to the agent class, which is this one, and there is a function actually called train model. So we scroll down, and here is the function train model. So CWD is current working directory, and the break step is coming from the total time steps. Then there's another function here, train and evaluate. Control click, and this is the actual training function. Here's where all the magic happens, essentially. All the GPUs are set, the environment is set, all the arguments are taken, and here's where so we are on policy. So this is not what we're doing here. We start training, break step, delete the arguments, and here is actually where we train. Well, train is true. We are going to explore the environment and try different strategies inside this environment. Let me get in here. Agent.explore environment. So we go back to the agent. Alright, I got a bit confused about where how this works in Google Colab, because normally I work in PyCharm. But okay, so if we'll control we are now looking at the run. Remember, we were looking into the train function, into the train model function. Hello. Okay, the agent, which is this agent, where we would go into train model, into train and evaluate, which will bring you to run, which will bring you to the actual training loop right over here. And then you have this explore env and function, and this is actually where, for example, here we go into agent.py, just double click it, and here you can see the agent base. This is a base class for all the other agents, and this has these functions, and after that, the basic functions. After that, there's a class for every single optimization algorithm. So here's DQN, here's of policy, here's agent TD3, agent DTBG, agent 3QN, agent double DQN, agent dueling GQN, whatever. These are all different kind of optimizer strategies. So we picked PPO. So if we go looking here for the PPO agent, sorry, agent PPO. So this is the one eventually which we will be using, and here you can see it's containing the explore env class. And so here it's actually updating the net and doing whatever proximal policy optimization would do, and adapting and overwriting the standardized base class functions which are created by the agent base. So let's go back to run. So that's where you can find the actual agent, and the actual functions which are used here, and to update the net. And then you have the evaluator, which is another class if you're interested. It's right in here. Can I open this? Hello. I'm struggling with this. Okay, it takes some time. Okay, the evaluator is a simple extra class which records the trajectory, evaluates it, how many times evaluated, the maximal reward. And if you want to look into it, this is what actually gets printed on your screen during the training process. And you can look into this class if you want to know what exactly those numbers mean. So now we're back at run. Train and evaluate run, and yeah, so it will stop eventually when it reaches goal, which is determined by a break step, and that is the break step gets updated every time in the environment. So let's go back into the agent one more time, just to show you that this is actually where it gets connected to the to the environment. Where's PPO? Here. So explore one env, and you see actually env.step. Oh well, gotta remember this because eventually here in the environment you have a function called step, and that is where it essentially gets connected to the environment. So remember that. That's good to know. Okay, so and that's it. Then it will print if it's done use time. So then we can go back here. Training will be complete. Train model. Then we can go back up again towards the train function, and we hit the train. We now have a trained model. So that is the train function. Took me some time to figure it out myself, but okay, that's it. Alright, now we go to the test function, which is the next cell. And now it's gonna get more easier because now you already know what the underlying structure is of these functions, which is quite deep if you have to figure it out yourself, I must say. A test function, same stuff as before. Alright, same stuff as in the train. Also same stuff. But then change the net direction, and it says the current working directory. This is actually where it loads your model from. So we are working in this directory, and we saved during training. We saved our model here in test PPO. This will be empty in your case because you haven't trained yet. I have to check it out. Then it chooses the elegant RL and does based on the trained agent. So it loads up the agent here from the current working directory, which is test PPO, and loads the net dimension and the environment instance and does a prediction. So you can now I learned it simply takes some time to open this. So control click, wait, and here you see DRL prediction. So gets the model, amount of environment, sets the arguments again, net dimension, tries to initialize the agent, and if it isn't loading your agent from this test from this file, it will throw you a value error, which is this one. Here then is actually the loop where it goes testing on the environment. So makes a list of your returns, total assets, and appends the initial total assets to your environment, which is your initial cache, and does the loop. So every time it just takes an action and then takes a step inside your environment, which again comes back to this step function in your crypto env class. After that gets state reward and recomputes the total assets, which is your cash plus the value of all of your stocks, appends that to the total assets, and looks at the return, which is your total assets divided by your initial assets, and appends that to the list of assets. If done, it breaks. So if the break step is reached, and then it returns your total return. So that's not so hard. So that's actually the test class. I'm ignoring this again, like I told you. And here we actually get to the trading environment. So this is the trading environment. This is the config. You have to supply it the price and the tag array, which is like told before. You build a data config dictionary here, and that's supplied to your environment. So then your initial capital assumes that you have 1 million here. The buy cost percentage is 1, which is like the fee on buying. For example, if you buy $1,000, you have to $1,000 worth or something. You have to pay €1 fee. Same for the sell cost, and the gamma, as a reinforcement learning guy, you should know what it is. It's the importance of future rewards. So just sets the look back. Is not implemented in this environment, so I'm not getting into that. total assets, per cost price explained, max stock not used here, I believe, gamma is gamma. So here price array and tag array are extracted from the data config lib dictionary as told before. The action normalizer is a way to align the size of all actions. So it looks at the order of magnitude of your of the prices, of the initial prices, of the initial price array, and then make sure that the actions are inside that order of magnitude. Alright, so for example, if you have Bitcoin it's 40k and Ethereum is 3k, then it will make sure that the eventual action is all in the same order of magnitude, which is nice. Okay, then crypto number is the size of the price array shape 1, so the second dimension. So your price array, if you have 10 coins, your rows are all the coins, and so it's rectangular for you. So this is the start of time, and here are all the rows. These are all the prices, and then it's the prices at each time step. So price array 1, the shape is the amount of cryptos you have. Maximum step, yeah. Self.time is the time instant, initial cache, it's current price. So this is all initialization of variables which will change during the training all the time. Give it a name. State dimension. So I'm gonna ignore the look back, but just to explain you what this is. So we have we have cache. This in the state. You have the prices. You have. Sorry, my runtime disconnected. Don't want that. Okay, so you have 1, which is your initial cache. Then it's the self price array dot shape 1 is the amount of stocks. So that puts 4, or if you're trading 10 cryptos, this part of the state will check how much you have of each crypto. Then in the tag array shape 1, there is in the tag array, yeah. So in the inside the tag array, there's the price data, so the OHL-CV data, and all of the technical indicators. So think of that. So we had, what is it, 5 technical indicators or 4? And then you have OHL-CV data, it's 5, so will be shape 9. Action dim, yeah. So we are doing action for each crypto. So if you have 10 cryptos, which is already counted, then the action dim will be 10. Reset is every time during training it passes a full the full data set, it will reset afterwards and continue training. And then we have the step function. This is where actually happens what would happen at each time step in your trading algorithm. So first we're going 1 time step in towards the future, so we add 1 there. Then we check the price at that time, and we normalize the action with the norm factor, which is, where's the norm factor? Self.action norm factor I, which in this function below here, during initialization, this action norm factor is set. So this happens at the start when the class is created, so it happens straight away. So then there's a self.action norm factor present, that's where this comes from, and it normalizes all the actions, so the order of magnitude is equivalent. Then for index where actions is below 0, so if the action is negative, it's a sell. If the action is positive, it's a buy. That's why. And this is just to avoid bugs, because there can be a hole in the data where the price I don't know is 0, or is just a bad piece of data, so we're just gonna ignore it if that's the case. Then it takes the minimum and then of the self.stocks index and the minus action. So if you have, for example, 10 bitcoins, for example, and your action is minus 3, and it's a sell, so this is minus 3, then it will do the action. But if you have 10 bitcoin and it's the action is minus 20, then it will sell all the possible stocks. Get it? So, and then the stocks after that are just the shares you had minus the sell number of shares, and the cash increase is the price at that index times number of shares times how much it costs to actually sell the fee of Binance or Alpaca or whatever. Okay, then here same stuff, except this one is a bit different. So the buy number of shares is this cash, the maximum number you can buy is the cash divided by that price. And so if your action is larger than what you can actually buy, then it will take the maximum amount you can buy and the rest the same. Then if it's done is self.time is when self.time equals maximum step, like the break step. The state gets updated. This is the state. It's a stack of self.cache horizontally stacked with numpy stocks, and then the normalized tag, which so we have cache stocks tag in the state, and then it returns state. So the state is updated after that, calculates the next total assets, and then looks at the profit made compared to in the next time step compared to the previous one, and this is a normalization. Machine learning likes low numbers, so that's why these numbers get normalized. Updates total assets and looks at the gamma return, which is something you should look into yourself, and then calculates the cumulative return. So if the self.time equals the break step, then the reward is equal to the self.gamma return and the total return is calculated, and then it's over. After that it will return if it's done, this will return into the explore env function of the PPO agent where we were at before, and then we'll break the loop and finish the training process. So I think that's the whole crypto environment already. So okay, so now the ticker list, as I said, all the trading pairs, they have to be available from your data source. So like for example, if I go to Binance, you have to make sure that they exist, and what's also a thing is you have to make sure that there's enough data points for your time frame compared to your train start date and end date, also for your test. So here's your technical indicator, so it was 4, and your URL prompts. So that's it. After this the tutorial is actually quite finished, I think. So we loaded all the new stuff, and we can possibly go training. Gives it a nice name, and I'm gonna pause the video again a bit. So I just explained this. It's now downloading all the data points from Binance. That's why nothing is happening yet. As soon as the download is finished, it will do this, exactly what happened now, and it will start training. If you want to know what these numbers exactly are, you can look them up in the evaluator we talked in before, a little bit back in time in this video. I'm gonna pause a bit. Just a small update for you guys. So if the target step is 5,000, so let me see. So it reached 5,000, which is the step, and now it will finish, and then we'll give you an output. The testing is way faster. We'll give you the account value of the elegant URL. Binance Connected has to download again the data, because remember, we want to be downloading on the fly, because in real life trading it will keep learning from each new data point. And we got a 7% return, so your original investment times 1.07, and we have had 2000 data points. At the technical indicators, it's all good. Okay, then let me. Okay, so the account value is the value of your the value of your total assets at each time instant, and the agent returns. Yeah, so the agent returns is the returns at each time instant, and then well, buy and hold is just the initial Bitcoin prices divided by uh, the the final Bitcoin prices divided by the initial Bitcoin prices. So that is also nice. That's a pretty good benchmark. Equal weight portfolio simply means that you have, for instance, you have 1 million and you're trading 4 coins. You just split your 250k for each coin. So that's an equal weight portfolio. How that's calculated, you can check into that yourself. And then we just plot, and we're finished. You see the elegant RL agent on the. We did it on 5 minute time frame. Is yeah, it made quite a few big losses, but eventually wins out. Okay, I think that was it. Was one of my first videos I made like this. I hope you liked it. Was a bit messy because I actually work in PyCharm, and I was not really used to using collab, so that's why I was fooling around a bit, but that was okay. Thank you.